This question is from GATE 2019 Mechanical Engineering paper set 2, question number 36. The crank of a slider crank mechanism rotates counterclockwise with a constant angular velocity omega as shown. Assume the length of the crank to be r. Using exact analysis, the acceleration of slider in the y direction at the instant shown where the crank is parallel to x-axis is given by. Let's find out. Let's mark some points first. Let this point be O, this one be A, and this one be B. Now, velocity at point A in the vertical direction can be denoted as VA and can be simply calculated as VA is equal to omega into R, because omega is the angular velocity of OA, and therefore velocity of point A will be omega into the distance from point A, which is R. Now at point B we can see that there is a constraint of movement in the x direction, and therefore B can only move in y direction, and therefore VB will be directed like this in y direction. Hence, if we denote velocity of point B with respect to point A at 90 degrees to the connecting rod denoted by VBA, then its x component, which is VBA cos theta, or rather cos 45 degree, will be 0. Now cos 45 degree cannot be 0, and therefore VBA has to be 0. So we have our result here that velocity of point B with respect to A is 0, but VB is non-zero because point B is going to move in the y direction because of this constraint when the crank rotates. VBA, the relative velocity, can be written as VB minus VA, and this is equal to 0. So we can say that velocity at point B will be equal to velocity at point A. VBA can be written as angular velocity of link BA into root 2. But now that VBA is 0, omega BA has to be 0 because root 2 is a constant value. Therefore we can write omega BA is 0. Since link AB does not undergo angular motion, therefore its angular acceleration alpha can be written as 0. We need to find the acceleration at point B. So we have identified that angular acceleration component is 0. So if we draw the acceleration diagram from point O, radial acceleration at point A can be denoted as r into omega square. So we'll direct this way because this is the direction of radial acceleration when the crank rotates. So this is r omega square, which is the radial component of acceleration. Also, we can denote acceleration of point B like this, directed upwards in the y direction. The direction is actually same as the velocity at point B. So velocity at point B is directed in y direction. Acceleration will also be directed in y direction. This is AB. This is the acceleration that we need to find. We can join these two endpoints of the vectors, and thereby we will have this as 45 degree and this as 45 degree. As we can see, the values are 1 and 1, so these angles are 45 degree angle. From this triangle, we can write tan 45 degree is equal to opposite upon adjacent side, so AB upon r omega square. Therefore, AB will be simply r omega square into tan 45 is 1. So AB is r omega square. Let's go back and mark this option. Answers given here include A also, which has a negative sign, but AB is directed upwards in positive y direction. So answer is option C, omega square r, and not A. To learn more about single slider machines, you can refer the NPTEL video module 4 lecture 1, balancing of single slider machines. This is from the course Dynamics of Machines by Professor Amitabh Ghosh. He is from Department of Mechanical Engineering of IIT Kanpur. I hope this solution will help you clear your doubt. Thank you.